Remember that you're following the integration what to do and when flowchart when you are answering integration questions. And remember that you've got the formulae in the integration differentiation sections of the formula booklet to help you. Question 18. We want the integral of x sine 2x from 0 to pi over 2. I'm going to do this by parts, because if I select my u to be the x and my v dash to be the sine 2x, then I think this is going to be a good idea, because when I differentiate the x, I just get 1, which is going to turn this into a nicer integral. Integrating the sine 2x, well, sine integrates to be minus cos. And I need to divide by 2 because of the reverse chain rule. Applying the by parts formula there, we've got u times v. So minus a half x cos 2x minus the integral of u dash times v. So 1 times minus a half cos 2x. I notice I've got a minus and a minus here, so that's going to simplify and just be a positive. Now to do this simpler integral, I know cos is going to integrate to be sine. But I'm going to divide by 2 because of the 2x on the inside there, so the reverse chain rule. So that half is going to become a quarter. My limits were 0 and pi over 2. So substituting pi over 2 in first, we'll get a half pi over 2 times cos of 2 times pi over 2, which is just pi, plus a quarter times sine 2 times pi over 2, which is pi. Substituting the 0 in, the first term will be 0 and the second term will be 0. Cos of pi is minus 1, times by the minus a half will be plus 1/2, times by the pi over 2 will be pi over 4. Sine of pi is just 0, and so the rest of this will all be 0, so my answer then is just pi over 4. Question 19. We've been given a curve there defined by the parametric equations x equals 5t squared minus 4 and y equals t times 9 minus t squared. And we need to, we're told that the x-coordinate of point A is minus 4 and the x-coordinate of point B is 41. We need to work out the area enclosed in the loop. So usually I would integrate y with respect to x between the x limits of minus 4 and 41. And that would tell me everything between the curve and the x-axis. So I would need to double this to get the whole area. We're obviously dealing with parametric integration here though. So I want this to be in terms of t. not in terms of x. And we're also going to be using the adapted parametric integration formula. So let's work out what is t when x is minus 4. So let's use this x formula here. If x is minus 4, then 5t squared would equal 0, so t would have to be equal to 0 at that point. When x is 41, we get that 5t squared is equal to 45. So t squared is equal to 9, so t is 3 or minus 3. Two different values, one for when the curve is going up through that point and one for when the curve is going back through that point again. I only need to use one of them though, so I'm going to use 3. So our lower limit was 0, our upper limit is 3. The y can be replaced with 9t minus t cubed. So let's plug that instead of the y here. The dx by dt, let's differentiate the x to get that. So if I differentiate 5t squared, I get 10t. Differentiating the 4 will disappear. So we're going to plug this into our formula. So the y was the 9t minus t cubed. The dx by dt was 10t. Let's expand those brackets so that we can integrate term by term. The 9t times 10t is 90t squared. The t cubed times 10t is 10t to the power 4. Integrating each of those, we'll get 30t cubed minus 2t to the power 5. Substituting our limits in, we've got 30 times 3 cubed minus 2 times 3 to the power 5. Minus, when we substitute 0 into each of those terms, we'll just get 0. Three cubed is 27 times 3 is 81, so that's going to be 810. 3 to the power 5 is 243. So this is going to be 286.